All right, let's dive right in. Today, we're going on a seriously mind-bending journey, right to the edge of what we even call reality. We're going to explore the truly strange connections between the quantum world, the wild idea of infinite universes, and maybe the biggest mystery of them all, our own consciousness.
So let me start with a question that might just change how you see the rest of your day. Every single time you make a choice, and I mean any choice, from what you had for breakfast to which road you took to work, what if in that exact moment reality itself splits in two? Now, this isn't just some plot from a sci-fi movie. It's a very real possibility that comes directly from our deepest understanding of physics. It's an idea that challenges everything we think we know about a single, solid reality.
But, to really appreciate just how bizarre things get, we've got to take a quick look back. Let's revisit the world we all used to take for granted, a reality that seemed to be built on solid ground and predictable, easy-to-follow rules.
You know exactly the one I'm talking about. It's that common-sense world where if you drop a glass, it falls and shatters. Every time. It's a universe that, for hundreds of years, we thought ran like a perfect, beautifully crafted clockwork machine. It's the world our brains evolved to understand.
And this right here shows the first major crack in that old, certain picture. On the left, you've got Newton's universe, a rigid stage where time and space were absolute, the same for everyone everywhere. But then, Einstein came along and completely flipped the script. He showed us that space and time are actually woven together into a flexible fabric. Gravity wasn't some weird invisible force pulling things, it was just the shape of that fabric bent and curved by mass. This was the first giant leap away from that predictable machine and into a much more dynamic, relative cosmos.
But as radical as Einstein's ideas were, trust me, things were about to get a whole lot weirder. So let's take the next step, the quantum leap. See, when you zoom way, way down to the smallest scales of reality, the rules completely change. One of the core rules down there is called superposition. The classic example, of course, is Schrödinger's cat. You put a cat in a box with a random quantum trigger. Now, according to quantum mechanics, the cat isn't just secretly alive or dead inside that box. No, it's literally both alive and dead at the exact same time, existing in this hazy cloud of pure possibility, right up until the moment we open the box and look.
And this experiment shows just how baffling that really is. In the double-slit experiment, if you shoot tiny particles like electrons at a screen with two slits and you don't watch them, they act like ghostly waves. They somehow pass through both slits at the same time and create a wave pattern on the other side. But here's the kicker. The instant you put a detector there to see which slit they go through, they snap out of it and start behaving like normal, solid particles, creating two simple lines. The takeaway here is absolutely astonishing. The very act of observing changes the outcome.
And if you thought it couldn't get any stranger, well, buckle up because there's entanglement. You can link two particles in such a way that their fates are forever intertwined. If you measure one, you instantly know the state of the other one, even if it's on the opposite side of the galaxy. It's a connection that seems to break the speed of light, defying everything we know about space. Even Einstein couldn't get his head around it, famously calling it spooky action at a distance.
So all of this weirdness, the superposition, the observation effect, the spooky connections, it all leads us to a central, massive paradox. A paradox where the bizarre rules of the quantum world slam right into our own role as observers.
So what is really going on when we look at that electron or open that box? Why does a world shimmering with infinite possibilities suddenly just snap into one single reality for us? This, right here, is one of the biggest, most profound, unanswered questions in all of science. And there are two absolutely mind-blowing theories about it.
So on one side, you've got the classic view, the Copenhagen Interpretation. It basically says that the act of us looking, of measuring, forces the universe to, well, make up its mind. It collapses all those possibilities down into the one thing we actually see. But on the other side, you have the many worlds interpretation, and this one is a trip. It says there's no collapse at all. Instead, every single possible outcome actually happens. Every single one. They just happen in their own separate branching universes. So when you make a choice, you're not collapsing reality. You're just finding out which branch of reality you happen to be on.
The brilliant physicist John Archibald Wheeler really ran with this idea. His famous quote gets right to the heart of it. He suggested we live in a participatory universe. Think about that. We aren't just passive spectators watching a movie that was already filmed. Instead, our observations, our very participation, might be a crucial ingredient in bringing the universe into concrete existence.
And if observation is the key, well, that forces us to ask a really deep question. What exactly is an observer? And this is the moment where the ultimate mystery, consciousness itself, walks right onto the stage. You know, science is incredible at mapping the brain. We can see the neurons firing, the electricity buzzing around, but there's something it can't explain, something called the hard problem. And it's this: why does all that physical activity feel like anything at all from the inside? Why do you have this rich, private, inner experience of seeing the color red, or feeling joy, or just the simple feeling of being you? That's the ghost in the machine.
So what if consciousness isn't a classical, clockwork process at all? One really bold, out-there idea is the Orch OR theory. It suggests that our actual awareness comes from tiny quantum computations happening inside these little protein tubes in our brain's neurons, called microtubules. Just imagine that for a second. In this view, every single moment of your conscious experience is the result of a tiny quantum collapse happening right inside your own head.
Okay, so quantum physics, branching universes, microtubules. Why does any of this actually matter to you and me? Well, because these aren't just abstract puzzles for physicists. They touch on the most fundamental questions we can ask about our own existence.
Let's really think about this. If reality branches every time a quantum choice is made, what does that do to the idea of free will? Are we really making a choice, or just discovering which universe we ended up in, while another version of you makes the opposite choice? And what about our role in the universe? Are we just tiny, insignificant specks on a rock floating through space, or are we something more? Are we maybe, just maybe, co-authors of the entire cosmic story?
At the end of the day, the real takeaway here isn't a neat and tidy answer. Honestly, nobody has one. Instead, it's a profound, powerful shift in perspective. This journey from a simple, clockwork cosmos to a weird quantum multiverse suggests that maybe we aren't just looking in from the outside. Maybe we are active participants woven into the very fabric of a reality that is far stranger, far more flexible, and way more interconnected than we ever imagined.
And maybe that's the most beautiful place to leave it. As the great physicist Richard Feynman once said, maybe the goal isn't to have all the answers neatly filed away. Maybe the real thrill is in living with the mystery, in constantly questioning, and in just embracing the magnificent, awe-inspiring uncertainty of it all. Thanks for joining me on this one.